In this video, we're just going to do 3 or 4 examples of normal distribution calculations using OpenOffice. So let me just throw something up here. Let's start with the standard normal distribution, which has mean 0 and standard deviation 1. Let's say we wanted to know what's the probability that z is less than or equal to 0.46. Well, it's not too bad. Just go to OpenOffice, hit equals. I've already got my statistical functions pulled up. Sure enough, there's one called normDist. If I look at what OpenOffice tells me, it says I'm supposed to put in the number, then the mean, then the standard deviation, and then some other condition. I don't know what that condition is, so let me show you how to look it up. Like anything, you go to Wiki. So if you go to the OpenOffice Wiki, the function I'm interested in is normDist. So put that in. And it says what? So sure enough, you put in the number, the mean, standard deviation, and then if the mode is 0, it calculates the probability density function. So that's just the bell curve itself. It just tells you how high you are from the x-axis. That's not what we want. We said before that in statistics, probability means area. So it says if the mode is 1, then it calculates the cumulative normal distribution function. So this is, like we were talking about in the last video, the area out to the left. And actually, if you don't put in a mode at all, if you just put in those first 3, it assumes you want to do this last one. So we're just going to forget about it and just tap in the number, the mean, and the standard deviation. But I wanted to show you how to look that up on Wiki, just in case you've never used the Wiki for a program before. So I'll hit normal distribution. My number is 0.46. The mean is 0. And the standard deviation is 1.677. So this probability is 0.677. Easy as pie. Actually, you notice in the list there's also a normSdist. That S means standard distribution, so you could have just said, okay, equals, hit that guy, and then put in the 0.46. You get the same thing out. In practical applications, though, you never have mean 0 and standard deviation 1, so I encourage you to just work with the full guy where you have to actually tell it, because this will come up in your homework where you just do mu 0 and standard deviation 1, but that never happens in real life. Alright, let's do a little more complicated one. Let's say we do, still sticking with the standard guy, mu equals 0, sigma equals 1. Say we wanted the probability that z is between 0.38 and 1.47. Well, we talked about this in the last video. If you draw a picture, here's 0.38, 0.38, and here's 1.47. We want this area in the middle. Well, what we can do is if we did n of 1.47, wow, I cannot put my decimal place in the right spot today. You can see that. Alright, so this guy would give us the area completely to the left of the 1.47. If I do the n of 0.38, that'll give me the area just to the left of 0.38. And so if I subtract that area off from the first guy, it just leaves the area in the middle, which is what I want. So what I'm going to do is just find normal distribution of both of them and then subtract the answers. So go back here, say this is equal to normal distribution. I'm just going to do the standard one to save time, but minus standard normal distribution of 0.38. Alright, so the probability that you're in between 0.38 and 1.47 is 2.8. Alright, let's do one more with the standard guy, and then we'll change the mean and the standard deviation. So let's go back to our empirical rule. So the empirical rule said, well, let's do, say, 2 standard deviations. So the probability that z is somewhere between 2 and -2. And we know this should wind up being 0.95, but let's actually just double check. It's just like the last one. We want to find the area that's to the left of 2. I don't want p, I want normal distribution. I want the area to the left of 2 minus the area to the left of -2. So if I go back to my guy, I'm just going to change the numbers here. So -2 and 2, and I typed them backwards. So, but okay. Sure enough, we get 0.9545. So actually, within 2 standard deviations on any normal distribution, you have 95.45% of the data. Cool. All right, well, let's do one where you don't have the standard, just for variety. So let's say our mean is 10 and our standard deviation is 2.5. Let's find the probability that, let's go with x greater than 11. The only reason I use x instead of z, people tend to use z for the standard guy and x for all the others. No real big deal. Again, if I use this function on my program, it gives me area to the left. So, well, here's 10, that's 12.5, so 11's about right here. My program's going to give me this area over here, but we want this one. And again, well, I know they need to add up to 1 because the probability of something happening, period, is 1. So that means what I'm actually going to do is I'm going to take 1 and then subtract off the left area. And for some reason, I cannot write, but it doesn't matter. You know what I mean. Normal distribution of 11. So yeah, just go over here and type equals, now I need the general guy. So my x is 11, my mean is 10, my standard deviation is 2.5, and I'm supposed to subtract that from 1, so let me go 1 minus. There we go. So this area that we want and the probability that we want is 0.346. Alright, so there's some examples of doing normal distribution calculations. In the next video, we'll actually solve some practical problems like this.